Thank you very much, Ms. Ruiz. Now we have better understanding of cooperative practice taken in the Baltic Sea regarding the management of ships' ballast water, especially the granting of exemptions between parties. Noting that this matter was raised by several contracting parties at the last meeting of focal points of RAMPEC, I hope this presentation provided you a glimpse of what could be carried out in the Mediterranean region. Speaking of management of ballast water and its associated risk assessment process, the collection and analysis of data is a crucial and indispensable part. Some data collection work has been carried out in the Mediterranean region by individual contracting parties and may have the potential to contribute to the effective management of ballast water in the region. Regarding this topic, I would like to invite Professor Georgios from the Odyssea project to share with us the information about the platforms, models, and what could be provided to support the implementation of ballast water management convention in the Mediterranean Sea. Professor, the floor is yours. Thank you.
Thank you very much. I'm Professor Sileos from the Democritus University of Thrace, and I'm coordinating Odyssea project. I don't know if I can have my presentation on the floor. I would like to thank the organizers.
Share the screen.
I would like to thank the organizers for inviting Odyssea project to present the achievements we have so far within the implementation of Odyssea. So I will present to you the outline of the project, the platform we have developed within the framework of Odyssea project, and the data we collect and the models we run in order to contribute to not only that, but of course one of the aims of the project is to contribute to BWM convention implementation. So can I have the next slide, please? So Odyssea is a Mediterranean-focused research project. It is funded from Horizon 2020, which is the main instrument in terms of research and innovation in the European Union. It comprises of 28 partners from 14 countries over the Mediterranean Sea, 6 of which are do not belong to the European Union. It has a total budget of 8.4 million euros. And it started on the 1st of June 2017. It's going to end next year, hopefully end of November. It is involves the work of 118 researchers working continuously in this research project. Can I have this next slide? So let me just briefly introduce you to Horizon, just to give the framework of what we are doing. Horizon is the main instrument for research and innovation. It dedicates around 80 billion euros over the period 2014 to 2020, in addition to private money, in order to develop scientific breakthroughs, discoveries, and to take the great ideas all the way from the lab to the market. This is why in Odyssea we have constructed a business strategy on how to approach this advancement in the technology readiness level of the various products and services we develop. And of course, in order to go from the lab to the market, you need to be in direct contact, in continuous contact with the various stakeholders and end users. Next slide, please. So one of the main strategies of the European Union is blue growth. And blue growth is the main strategy, is a long-term strategy in order to support the sustainable growth in the marine and maritime environment, in the marine and maritime sectors. And it is a strategy which contributes to the main European pillars, which consist of the smart, the inclusive, and the sustainable growth. European Union recognizes that the seas and the oceans have great potential for innovation and growth, and for this reason, through Horizon, new ideas are being funded. And the key word here is jobs and sustainability. So when someone develops a tool, develops a product or a service, it has to be sustainable after the period of funding. Let's go to the next slide. So let me now briefly introduce you to the concept of open marine data. Presently, there are plenty of platforms available containing marine data, most of which are open for the broader public, for experts, managers. But what we have seen through our research is that very limited number of people have the capacity to dedicate time to retrieve all this data, to access the data on a day-to-day basis and utilize this data for their operational decision-making. This is a main drawback of all these systems. And what we are trying to build in Odyssea is to develop a unified system, a system of systems, let's say, which will incorporate all the data coming from the various data providers, coming from the different platforms that exist throughout the marine and maritime world, in order to provide to the user the easy access and easy capacity to make this data transformable into information and reach decision making, help them to reach decisions. So this is the main aim of Odyssea. I will speak a lot about it. Let's go to the next overhead. So one of the things, as you know, now we live in the era of big data. One of the things, however, of big data is how to transform them into valuable and meaningful information. For example, here we have an example that says that in one position in the ocean, in a specific time, we have the temperature, the water temperature being at 28 degrees. And then we need what is called an algorithm, a manipulation and processing tool, which says, for example, that if water temperature is higher than 26 degrees for a period higher than 5 days, then take care, because heat stress might affect your aquaculture. And this might lead to a high probability of fish mortality, which is extremely important for the fish farmer to know. And all this system is a system which takes the raw data and transforms them into something which has a value, and it can be translated into a monetary value. This is what we are trying to develop in Odyssea project. So let's move to the next slide. In the real world, we have more complex systems. We have a lot of data, big data, as I said. We require algorithms to manipulate all this data and process them. But then we have the forecasting capacity that the models give us. So we have the tools as numerical models or any type of modeling tools give us to forecast and predict the conditions that we will have in the next days. And then we translate all this into information. And then we are building what is known as knowledge bases, big databases that take into account diverse data and aid again the informed decisions. So in Odyssea, we are trying really to develop these ecosystems of tools that lead to the final user, to aid, to support him for informed decision making. Let's move to the next slide. All this is done within an environment which gives particular attention to the sustainability, the long-term sustainability. That is why, as I explained in Odyssea, we are developing a business strategy in order to develop these tools, these services for the end users, for the stakeholders, but to ensure that all the systems will remain there after the end of this initial funding that we have through Horizon. So in order to achieve that, we are in continuous consultation with our users, with the people that might use the tools and the services we develop, in order to see their needs, in order to adapt our services and products according to their needs. So we are seeking really for a series of funding that will help us sustain all the operational services we are developing within this project. Let's move to the next. The center is that we are a user-centered project. It's a data-driven, user-centered project, aiming to make the Mediterranean marine data easily accessible and operational to a series of diverse, multiple end users. And we will do that firstly by harmonizing existing Earth observing systems. So we take all the data from existing Earth observing systems like monitoring databases, satellites, models, online sensors, and we harmonize them and inject them in the platform that we have developed. In parallel, we upgrade the operational oceanographic capacities by downscaling existing operational oceanographic and environmental of the EU policy by providing data that have never been previously recorded, so that we aid and support the implementation of policies like Water Framework Directive or the Marine Strategy Framework. We improve the interoperability in monitoring because we measure something once and we use it many times, achieving what is called as cost effectiveness. We are trying to foster blue growth creation of jobs, and we open the participation to non-EU member states. Let's move to the next slide, please. So the main pillars of Odyssea are the following. You can see them summarized here. From one side, we have the platform, which is the main deliverable, and it's the system that the end user will see in front of him when the computer is on. It's a novel and easy-to-use system which integrates and aggregates all the data that are available for the Mediterranean Sea. On the other side, we are deploying a series of novel sensors that we are building within the project. For example, for the first time, we are recording microplastics in the sea through a sensor that is developed within Odyssea project. So we are developing and deploying sensors that measure real-time the conditions in the marine environment. Then we run a series of models, downscaling the existing models that exist for the Mediterranean Sea. And we are coupling all these models in order to fulfill the needs of the various users, as I explain later. And at the end, we want to integrate all this and make this and package all this information into a series of services. So services and products that will be available to the end user. So in order to do that, we employ a series of modern tools like artificial intelligence or machine learning tools, or data fusion tools, in order to make algorithms that are at the edge of science. Let's move to the next slide. So Odyssea is a system that bridges the gap between the operational oceanographic capacities and the need for marine data, marine information, and the conditions which take place in the sea or will take place in the sea from the marine community of end users. And our ambition is to develop an interoperable, fully integrated and cost-effective multi-platform network of observing and forecasting systems which runs across the Mediterranean basin. This is you can see, I believe, a slide which shows really the basic data flow in Odyssea system. You see on the top of this diagram the various data providers, satellites, models, databases that are fed to the platform. Of course, there is a series of algorithms that harmonize all this data and inject them in the platform. And then we have the post-processing of the data, the manipulation, the development of WebGIS environment for the user, and the users are located at the bottom of the slide: the industry, public authority, science, civil services, and all others. But of course, we not only use that, we have at the right-hand side, you can see that we are focusing our efforts in specific parts of the Mediterranean Sea, and we have what is called observatories. So we have 9 observatories, 9 pilot areas, most of which are trying to cover and fill in the gaps that we have in knowledge, and we focus in the area of Northern Africa and Middle East. There we have intensive monitoring and modeling activities. Let's go to the next. Thank you. So the main novelties is that we will develop a single command platform with one portal in order to give the user all the data that are available through the other platforms and systems. We allow the users to search, to collect, to retrieve, to integrate data, and to reduce the costs, and therefore to make a system which could be used for a day-to-day operational and informed decision-making. We, as I explained, deploy sensors. We don't deploy sensors through the oceanographic way of thinking somewhere in the open sea, but we try to deploy our sensors next to existing facilities, onshore or offshore, like oil and gas terminals, maricultural installations, ports, harbors, in order to have a direct link with the user and provide directly the data to the user. We also develop and build gliders where we integrate microplastic sensors or other sensors for real-time biological monitoring. At this time in the Thracian Sea, we have a glider which is an autonomous vehicle that runs and collects marine mammals data, acoustic data. Operational models are also run, and they are coupled in each observatory and provide forecasts for emergencies and risks. And we train, of course, all these people or these end users on the use of the platform. Let's move to the next slide, please. So this is the platform as it stands right now in version 0.8. You can, and when you enter the platform, you see that the environment allows you to see the various sensors that operate in the sea at each specific time. You can click on each particular sensor and retrieve all the data that has been collected, or retrieve the data that are currently collected. You can see that on the left side there is a black margin which gives the opportunity to the user to very easy, with only one click, select what he would like to see, either time series data or mapped data, gridded data. And on the right hand side, you will see that through this menu, he decides what sort of data sets he wants to access and retrieve. So with the red dots here, you see the static systems that exist in the Mediterranean Sea. In Odyssea, we are enriching the existing static systems with more systems that will be deployed in Morocco, in Algeria, in Tunisia, in Egypt, in Israel, in Turkey, and in Greece, in North Aegean Sea, in the Adriatic. Let's move to the next. And with the green colors, you can see here the mobile sensors. So if someone clicks on a specific sensor, he will be able really to retrieve the data to make any type of diagrams. Here you can see, for example, the tidal variability of sea level, which is measured in a specific port. In case the sensor gives us salinity or temperature or any type of data, water quality, or currents or waves, he will be able also to make these nice diagrams, and very easily by clicking on each of these 4 selections at the top of this graph, he will be able to download the data to his computer for further manipulation. Obviously, in the next phase, we will not only give you this opportunity to the user, but we will provide all the tools that the user will need to process the data within the platform. Let's move to the next. So here you see a nice diagram. You can, by just clicking twice your mouse, you will have on the left-hand side to decide which is the appropriate product of data you would like to see. And by clicking on the right side, you can decide which parameter you would like to plot. And very easily, you can see water temperature. This is a map that I did yesterday. So this is the distribution of water temperature over the Mediterranean Sea. You can zoom in any area. You can, for example, if you are a harbor and port manager, you can zoom in any area of the Mediterranean Sea and see the conditions in terms of temperature, salinity, chlorophyll, or currents or waves, or any type of data which is available through the platform, the winds, of course. All these data are easily available, and if you are an operator of a shipping company, you can again assess the conditions and the forecasts of the weather and the winds and the currents over the track of the ship. Let's move to the next slide. So here you see the currents. As I explained, there are very nice images which give you an idea about the speed and the direction of the currents. You can see at the south of Crete there are very nice vortices of the water. These are the surface currents. You can very easily move to any depth you would like and see the various currents over the water column. The same applies to all properties. And again, you have to the right-hand side, you have the capacity to select the different data products that you would like to process or to visualize. And you see here that you have a scale so that you can change the scale according to the user needs and make your maps. And of course, this is something that could be used on a day-to-day basis for people that are operating from shipping industry in the open sea, but also for port managers and authorities. Let's move to the next slide. Here you see the conditions of the waves, the significant wave height. As I explained, models are run, and you can not only have the previous conditions, but you can have the present conditions. You see here in this time series diagram, there is a red dot which says exactly where we are in time, and you can see the forecast over the next period. So if you click in any position over the map, you can have a time series diagram and again easily retrieve the data. This gives us a great opportunity to say that data in Odyssea are distinguished in 3 main categories. So the user can go back in time for a few years or decades, depending on the data set, and collect all the data that are available for any specific location. So we have the historical data sets, we have the conditions of the sea right now, the real-time conditions, and then we have the forecasted data. So 3 different types of data are available through the Odyssea platform. Let's move to the next slide. And of course, the wind field, the weather conditions are extremely important when someone manages the maritime environment, from the maritime sector in the Mediterranean Sea. And you see here the forecasted conditions for tomorrow. Let's move to the next slide. We can zoom in specific areas of interest, the observatories that I told you earlier, and this is the areas that we run high-resolution water quality, hydrodynamic and wave models. For example, you see here the conditions in Morocco or in Israel or different areas that we have particular interest and we focus over there. So we give highly accurate and in high resolution information about the conditions the environmental, the oceanographic conditions, the hydrodynamic, the hydrographic conditions in the sea. Let's move to the next slide. So this is the main idea about the models that we are running. We are running a series of models that you can see here. The hydrodynamic model that creates currents and the distribution of temperature and salinity. We are running a biogeochemical model that creates the water quality in terms of pollutants. We are running a wave model that creates the wave height and direction and the wave period. We are also running oil spill models when the user requires, so that as soon as we know the hydrodynamic, the wind field, or the waves, we are able to develop any scenario for an oil spill dispersion. We are running also ecosystemic models for fishery managers, and we are running mussel and fish farming models for this type of operators. All these are run in the background, and the user will just be able to see an easy-to-use interface. These models are very easily replicated, and this system is very easily replicated all over the Mediterranean Sea. We can move it in any place of the Mediterranean Sea like a copy-paste process. So if there is a specific interest in a specific part that we don't cover presently, we can cover it very easily within a day in tomorrow. So this is the process that we have followed in Odyssea project. Let's move to the next slide.
I'm sorry to jump in. Before going to the next slide, please,
yes.
Yes, please. Just.
I'm at the end of my presentation.
Okay,
so I just want to say that we are also integrating a lot of biological data, which is of particular interest for the ballast water convention implementation. And these biological data are significant for all these studies that you are doing and for the exemption certificates that you discussed earlier. And we are able to understand the vulnerabilities, the risks, and the changes that take place in a local and regional level. Let's move to the next slide to show you an example. For example, here we have all the data of the Mediterranean Sea in terms of seagrass. This is a data set that has been collected from UNEP, and we have included also the data coming from the environmental, the oceanographic, the water quality conditions, and we are asking a simple question: why we have seagrass species, this particular seagrass species, in one location, we don't have it in another location. So we, through machine learning and artificial intelligence tools, we are able to understand the limits of presence or distribution of a particular species in the Mediterranean Sea, and understand the physiology and the ecology of the species and how this species is expanding or is being threatened by human activities. So we are running what is called species distribution models through these advanced algorithms. Let's move to the next slide. Here you see, for example, for the seagrass species, the various conditions that favor the different families, the different species of seagrasses in terms of chlorophyll and in terms of salinity. This is something that was reported for the first time based on this data fusion between the biological and the oceanographic environmental data sets. Let's move to the next slide. And I will show you now another example. For fisheries, here you see a species, a fish species, it's the common anchovy, and you see again for the various conditions what is the limits and the areas that is mostly found. This is again an integration of data between aquamaps from fish base and the data coming out of these environmental oceanographic data sets that we fuse in Odyssea. Let's move to the next slide. So we apply artificial intelligence tools in order to take this coarse map distribution of the species. Again, this can be done also for invasive species, alien species, and we develop this at the bottom of this slide, the high resolution maps that you see about the distribution of the species and the habitats and the areas that it prefers in terms of the oceanographic favorable conditions. Let's move to the next, please. So just to finish my presentation, Odyssea is a high-resolution marine information system for Mediterranean Sea, combining abiotic and biological dataset. It can aid the implementation of the BWM Convention by cooperating with port authorities and shipping companies to provide a service in line with the requirements of Ballast Water Convention. More specifically, firstly, develop customized operational high-resolution water quality and ballast water dispersion models for specific ports. So when ballast water is being released, we can see and we can forecast where it will go. Secondly, to develop tools for alien invasive species, early detection and control. Thirdly, to employ artificial intelligence and machine learning tools to distinguish between naturally, let's say, alien invasive species from ballast-related invasive species. Fourthly, to utilize existing data sets to produce risk assessment tools following the HELCOM OSPAR algorithms and experience, and to assess the risk associated with the discharge of ballast water by a ship at a specific port. And the final slide. So this is the roadmap we propose: analyze the data that could be collected, will be collected by the ports within the implementation of the convention. All this data could be transferred to the Odyssea platform and being fused with the oceanographic environmental water quality data and analyzed by Odyssea experts. We can cluster the ports according to the physicochemical and ecological characteristics, again, to be developed by Odyssea experts, run models, tools, and risk assessments to produce reports on ship vessels through our algorithms, and based on the risk assessment, produce or prohibit exemption certificates, again, but this time this is carried out by the maritime administrators. Thank you very much.